Dear students, today we are going to learn some more gas laws, that is Charles law, Avogadro's law and Gay-Lussac's law. The questions relating those laws and answers and explanation. Today the first question is, state Charles law, give its mathematical expression. For Charles law there are two definitions. The first definition is, at constant pressure the volume of a given fixed mass of a gas is directly proportional to its absolute temperature. At constant pressure and fixed mass of gas, the volume of a gas is directly proportional to its absolute temperature. So, when P and M are constant, V directly proportional to T, capital T. Capital T is nothing but absolute temperature. How can you get the absolute temperature? Absolute temperature is equal to centigrade temperature plus 273. That means V, if you increase the volume, the temperature is also increased. If the temperature is increased, the volume is increased. So, if one is increased, the other is also increased, that is called directly proportionality. If the one factor is increased, the other factor decreases, that is inversely proportionality. For example, you are seeing TV serials and cinemas etc. are increased, then the marks will be decreased, that is inversely proportionality. The marks in chemistry or marks in subjects are decreased. If your studies and hard work is increased, your marks also increases. So, that is a proportionality, directly proportionality. So, V directly proportional to T, that means as the temperature increases, volume increases. As the temperature decreases, volume decreases. So, the V directly proportional to T, V is equal to KT, V by T is equal to K. At constant pressure for a given mass of a gas, V1 volume at absolute temperature T1, that is the first stage. And if its temperature is changed to T2, the volume will be V2, volume is also changed to V2. According to Charles' law, the first stage V1 by T1 is equal to K, and second stage V2 by T2 is equal to K. Both are constant for a given mass of a gas, this at constant pressure. So, V1 by T1 is equal to V2 by T2. This is also a good relation, good formula to do some problems on Charles' law. Or you can cross multiply it, V1 by V1 T2 is equal to V2 T1 also there. So, what are isobars? Plots drawn at a constant pressure between two variables such as V and T, volume and temperature, are called isobars. Isobars are plots or graphs drawn at constant pressure between two variables. So, already we have seen isotherms. Isotherms are plots or graphs drawn at constant temperature between other two factors P and V. That is we got Boyle's law, Boyle's curve, hyperbola. Here the plot drawn at constant pressure between volume and temperature, volume and absolute temperature. This is you will get a straight line which is passing through origin. This is called isobar. Isobar is a plot drawn at constant pressure between any two variables. Second definition is also there for Charles' law. It is a if you want to know the temperature, if you want to take temperature in degree centigrade, then this definition is to be written. Actually, that definition came from this actual definition. This is the actual definition, but we are mostly used that definition, volume directly proportional to T. Here you see, at constant pressure for a fixed mass of a gas, volume of gas increases on increasing the temperature by 1 by 273 part of its volume at 0 degree centigrade. If you take a volume at 0 degree centigrade, that is a constant. Every degree rise or temperature degree rise or degree decrease, that changes the volume at V0 by 1 by 273 part. That means, when you increase the temperature by 1 degree, then the volume will be V0 plus V0 at 1 by 273. If you increase the temperature 2 degrees, V0 is the 0 degrees volume. This is V0 is the 0 degrees volume, 2 by 273, 2 degrees centigrade by 273. T degree centigrade is rise is there or decrease is there, decrease then you will take minus, increase you are saying, so T by 273 V0 addition or increment to the 0 degrees volume will be happened when the temperature is increased to T degrees, the volume will become this much is happened. So, finally, you can write the volume at T degree centigrade V is equal to V0 plus V0 into T by 273, that is equal to T degree centigrade, the volume at T degree centigrade. So, you take the common of V0 1 plus T by 273, T by 273. LCM you take 273 plus T0 degree centigrade by 273. 273 is a constant, so I have taken out from brackets V0 270 by 273 into 273 by T degree centigrade. You know, T degree centigrade plus 273 is called capital T. V0 is a constant, there is a volume at 0 degree centigrade, and 273 is a constant. This factor is also constant K, let it is K. V is equal to K into capital T, V is equal to KT. V, if you remove the K, V directly proportional to T. This is also is Charles' law. Charles' law, what is the definition? Second definition, actual definition, you can say, at constant pressure, for a fixed mass of a gas, the volume of any gas, the fixed mass of a gas is happened for every degree is varied or changed, for every degree change in temperature by 1 by 273 parts of its volume at 0 degree centigrade. So, now let us see the next problem. At constant pressure, find the temperature to double the volume at 0 degree centigrade. At constant pressure, the gas is taken, that gas temperature you have to find out when the volume is doubled. Volume is doubled at 0 degree centigrade. That means, initial temperature is 0 degree centigrade, the volume is V, V1 is equal to V initial stage, and T1 is equal to 0 plus 273 Kelvin, and the final stage V2 is equal to 2V, volume is doubled, to double the volume 2V. What is the temperature required? T2. T2 is a question mark. So, according to Charles' law, you know the relation between two stages, V1 by T1 is equal to V2 by T2. V1 is equal to V, V2 is equal to 2V, T1 is equal to 273, T2 you want, 2 to question mark. So, T2 is equal to 2 into 273, V we cancel out. So, here 2 is there, 2 into 273 is equal to T2. So, 546 Kelvin. If you want in centigrade, you subtract 273 from 546, you will get 273 degrees centigrade. So, if we give centigrade, you add 273 to get Kelvin scale or absolute scale temperature. If he gives the absolute temperature, remove or subtract 273 from absolute temperature, you will get centigrade temperature. Define Avogadro's law. So, it states that under similar conditions of temperature and pressure, equal volumes of all gases contain equal number of molecules or moles. When temperature and pressure are constant, equal volumes of all gases contain equal molecules, equal moles. That means, V increases, the moles also increases. V decreases, when V decreases, the moles also decreases. So, it can be written when P and T are constant, V directly proportional to N N is equal to number of moles. V is equal to Kn, V is equal to Kn, V by N, N is equal to K, V by N is equal to K. The graph is also like this. It is also V, if you take the graph between V and N, it gives a straight line. It gives straight line. It gives straight line. See, it gives straight line. It gives straight line. V versus N, the graph is straight line passing through origin. So, V directly proportional to N when P and T are constant, V is equal to K into N, proportionality constant K, V by N is equal to K, where K is equal to constant. If you want to take in graph when P and T are constant, V versus N, the graph is the plot is straight line passing through origin O. Next one is state Gay-Lussac's law. State Gay-Lussac's law. At constant volume, the pressure of given fixed mass of a gas. At constant volume is constant now. The pressure of a fixed mass of a fixed amount of gas directly proportional to its absolute temperature. P increases, T also increases. As T increases, P increases. T decreases, P decreases. So, it is expressed as when V and M, volume and mass, are constant, P directly proportional to T. P is equal to KT, P by T is equal to K. P by T is equal to K. In two stages, if you take P1, initial stage P1, temperature is T1. If it is changed to P1 to P2, then T1 is also changed to T2. So, according to the Gay-Lussac's law, in initial stage P1 by T1 is equal to K, constant, and say final stage or second stage P2 by T2 is equal to also constant, P1 by T1 is equal to P2 by T2, the relation. So, what is isochore? Isochore, this is also very important bit for the 2 marks. Plots drawn at constant volume between pressure and absolute temperature or a fixed amount of gas is called isochore. That is nothing but graphs drawn at a constant volume or between any two variables is known as isochore. Isotherm at constant temperature, graphs drawn at constant temperature are called isotherms. Constant pressure, graphs drawn at constant pressure are called isobars. Graphs drawn at constant volume are called isochores between other two factors. Graphs drawn at constant volume between pressure and at absolute temperature is called isochore. For example, if you want to have T degree centigrade, P versus T degree centigrade, then there will be intercept, that is V0, P0 this is minus 273 degree centigrade, this is absolute 0. Similarly, in Charles' law also you will get V directly proportional, V and T degree centigrade, same intercept V0, this intercept here is V0, because the y-axis you will take and Charles' law volume V0. This is also minus 273 degree centigrade, this intercept the x-axis. So, that is minus 273 degrees centigrade, that is known as absolute 0, where the volume or P pressure will become 0. So, the Gay-Lussac's law is also called as Charles Gay-Lussac's law. Charles Gay-Lussac's law. Thank you. Thank you for watching. Please subscribe.